Okay, 5.7, predicting with linear models. I think you'll find tonight's video to be pretty easy. It says sometimes data can be represented by a linear equation. By looking at a scatter plot, you can determine if a linear model is appropriate if the data can be well fit by a straight line. Let me just give you an example of what we're talking about here. So let's say you have these two scatter plots. The one on the left we would say could be represented by a linear model, and the one on the right would not be well represented by a linear model. And one of the ways of telling is just to kind of decide, okay, what type of best fit line would work for my given scatter plot. And the one on the left, is that an upward trend or a downward trend? It's definitely upward. I'd say it's definitely linear. And if you had to create a best fit line, you could probably come up with an actual line, something like that, right? Whereas on the right, there is no best fit line for this guy. I mean, it's not linear. If you try something like that, it doesn't really work. If you try something like this, it doesn't really work. Maybe we could talk about a best fit curve, perhaps, and maybe we end up with something like, a parabola, which we'll get into a little bit more in second semester, something from a quadratic model. But there's not a linear model that could really represent the one on the right. So your job is just to determine if something can be represented by a linear model, yes or no. Pretty easy. Two terms that have come up a little bit so far this semester, but we're going to start to use them more. It says when we use a linear model to come up with a line of best fit in order to estimate data points that are not given, we use either linear interpolation or linear extrapolation. And these are two vocab words that you should become comfortable with. All right, so interpolation is a method of estimating the coordinates of a point that lies between two given data points. Okay, so think of interpolation as guessing a value that lies in between two known values. Okay, extrapolation you can think of as guessing a value that lies outside the data point. And you can really just look at the word parts here to help you with that. When we see enter, enter there means between. And the pole, you can think of the poles as like the numbers, right? So if that's a pole and that's a pole, and these are two numbers, we might be guessing a value that lies in between them. That would be considered interpolation. Okay. Contrast that with extrapolation. Extra means outside, right? So we're going to be guessing a value that's outside of the known numbers. And those poles, you can just, I think of them as like the little poles on the number line, like the little hash marks. Outside the numbers versus in between the numbers. And let's take a look at what we're talking about. Okay, so here's an example where we can talk about both interpolation and extrapolation. And so what I want you to do is take a look at this scatter plot. You have already been given a best fit line, okay? And you're going to use that best fit line to help you answer the two questions below. This is your only example tonight. You don't need to copy the scatter plot. You don't need to draw the best fit line. But what I do want you to do is write down the words interpolation and extrapolation. I want you to write down a quick definition for each one, and then I want you to answer these two questions. One of them will use interpolation skills, and one of them will use extrapolation skills, and I want you to try to be aware of which you are using while you are answering the questions. So go ahead and hit pause now, do those things that I just asked you to do, and then unpause. We'll go over answers, and then we'll be good to go. Okay, so remember, interpolation is guessing a value that lies in between the known data, and extrapolation is guessing a value that lies outside the known data. Okay, the first question says, how much would somebody earn with 17 years of experience? And you'll notice when you look down here at years of experience, there is no 17. Now, you guys have already been practicing this skill since you were in elementary school, but you want to be as precise as possible. So where would 17 lie? Okay, it's definitely not going to lie anywhere over here, and it's definitely not going to lie anywhere over here. We know that it's in between 15 and 20, but you want to be careful. I wouldn't say that 17 exists right there. That's a little bit too close to 20. We know that 17 is in between 15 and 20, but it's a little bit closer to the 15, right? Because 17.5 is half. So maybe I might place my idea of 17, somewhere right there. And the point is, and you kind of usually do this visually, if you want to answer that question, one way to do it is to kind of mentally travel up from that point towards your best fit line. And the point on the best fit line that's directly above where you think the 17 is, this is probably going to be your best guess. Okay, notice that that point did not exist in our scatter plot, but we're using our best fit line as the best representation of our scatter plot. So a good answer, a good estimate for this question would be 50. And you can see I'm kind of breaking the cardinal rule over there. If you look at the y-axis, it says income 20, 30, 40, 50, 60, 70. You can probably tell I'm not going to like that. We need to quantify that. So what do you think that those numbers might represent? We are probably talking about thousands of dollars. So thousands of dollars. And then I can answer 50,000. All right, how much would somebody, oh, that doesn't even make sense. How much would somebody earn with 40 years of experience? Okay, is this going to be interpolation or extrapolation? Well, in the first one we used interpolation. Here we're going to use extrapolation. How much would somebody earn with 40 years of experience? You can notice that 40 is not even located on our x-axis. So we're going to have to imagine where 40 would exist. And if we kind of follow that pattern, maybe 40 is somewhere out right here. And I'll do this one in blue. Okay, so how much would somebody with 40 years of experience earn? We would want to travel up. Now you'll notice that we're definitely outside the data now, right? But one thing I can do is imagine where my best fit line would extend. And it looks like we're talking about a point somewhere around in here. And that's not going to be perfect, okay? But a point somewhere around in there. And now we have to extrapolate on the y-axis as well. So 50, 60, 70, perhaps 80 would be right there. It's a little bit above 80. 90 would be like right here at the base of the P. I'm looking like I'm a little bit above 80 but below 90. I might extrapolate something like 82. Of course, that's in thousands of US dollars. Now, you might not have come up with 82 exactly. If you probably said anything in between 80 and 90, you would receive credit. When we are extrapolating or interpolating, it's never going to be an exact answer. So usually there's going to be a range of acceptable answers. Apologize for the redundancy in the woods here. How much would somebody earn? We should get rid of that. Now it makes a little bit more sense. And once again, the only thing you need to have on your paper are the answers to these two questions and a brief definition of interpolation and a brief definition of extrapolation. And that's the easy video for tonight. So enjoy virtually the night off, and we'll see you in class next time.